Okay. So there's we almost never make Win32 projects. I don't know if they would ever teach it, but they're super out of date. You never use them anymore. Win32 console applications is almost how every single game starts. Any Xbox game, any PlayStation 4 game, any PC game typically starts as either an empty project or a console application. And it's okay to start with a console application because they almost have nothing in it. So we're going to call this the Advanced Prototyping Engine, the AP engine. Okay. This is a very standard kind of setup. You typically use precompiled headers for speed in development. They make your compiles faster, so something you typically want to be able to add. And I'm sure you guys have done this before, like creating a project, but you hit F5. You should always build first before you get into anything, so you should see a console show up and then go away, right? Okay, this is a standard one. To make an engine, it's really not that difficult. An engine typically is while true, do something. You're going to usually have a loop, and you're going to usually have a draw. And other multi-threaded engines have these things happening at the same time, so you can do work to draw to the screen as well as update your game at the same time. But just real quick, we're going to just make an empty loop and an empty draw. And in these things, I'm going to just do printf looping. And then we're going to do a printf here. Okay. So you can see that's actually what it's doing, right? This is what an engine is. It's drawing and then it's looping, right? And these are called frames. So if I do printf, right? This is what an engine is. So all we have to do is stick some behavior in the draw to do something, and then we can, in our loop, update our game objects, like move objects around, handle collision, handle input, update AI, whatever we want to do. Okay, does that make sense so far? Anyone have any questions on this? Like, stop me before I go any further as far as like questions on what I just did. Everyone understand the concept of functions? Yeah. Calling functions here. Everyone understand the concept of this loop? This loop will never end, right? We're going to change this so that this loop ends as soon as you press escape, but for now, this is what a game is, right? I can't actually do anything, I can't exit it, but this is how a game engine starts, okay? Pretty simple, right? It's not really that complicated. So now we're going to link in something that lets us do draw to the screen, okay? This is nice and all, but we want SFML in here so that we can actually draw like circles and squares and all that good stuff, right? So typically I go to the tutorials page. There's like this link here for setting up with Visual Studio. The biggest thing is that you need to do two things. You need to include the headers, and then you need to include the libraries that you're going to use. So you don't typically include the headers here. You add header files here for headers that you make. Because you didn't make the SFML files, you're actually just going to do an include, right? So for me, I'm going to save this project. I think this all got put into Visual Studio projects. So there's my AP engine. I'm going to put SFML outside of the engine. So I'm just going to put the folder here next to it. And then while I'm doing that, I'm going to do two things. One, I'm going to include the header that I need. So if you look here, there's this header that this guy includes, SFML graphics HPP. It's because here, in the include directory, there's an SFML. You see it says SFML graphics HPP. So there's actually a graphics HPP here. All right, so I need to get this folder inside my include path. You guys have done this before, I hope?
Yeah.
Okay. Typically I do this. I'll do all configurations. Oh, one more thing. There's no 64-bit configuration here, so I actually need to make one. I downloaded 64-bit binaries, which means this is Win32, which means it's a 32-bit version of binary. So I can make an x64 version instead. Okay. So then I do this for all platforms, all configurations, all platforms, because it's the same. This path is always from the directory of your project. So I go here. Where's my project folder? Here. There's my VCX proj. So I got to go up 1 level, 2 levels. Okay. So I go up 1 level, 2 levels. Now I'm here. Go into SFML dash 0.2. Okay. Slash include. Right. Hit OK. Then I'm going to just do include SFML. You can see it's actually auto-completing for me, right? Finding that file. And I'm just going to build. It'll tell me if I set it up improperly because it'll just give me an error. If I mistype that header file, it'll give me that error saying I can't find the file. If I go in here and I mistype this, like let's say I didn't go up enough directories here, I deleted that, and I compile, it'll give me the same error because I didn't set up my include. So before I even write any SFML, I'm going to set up my includes properly. So now it actually finds the header file, which means now I can start using those functions. It's not going to compile properly, but I can actually start writing this stuff. So the first thing I'm going to do is make this render window, and we'll just do the same loop that they're doing here. All this. Okay. Compile. It'll give me linker errors now because I didn't include the library, right? Anytime you see unresolved external stimul, in this case typically it means I didn't do the next step, which is to include the libraries. So that's the next bit here. So including a library means here, I'm going to debug this time because that's what I'm doing. The additional dependencies is where I start typing in the library files. So this is the list of things that you need to include. So if I want to use SFML graphics, in this case that's what I'm going to do. SFML graphics, which also means I need these. Okay, which means I need window, which means I need these. Okay, which means I also need system, which means I need this, which is already included here. The SFML system is already in here, so I don't need that. OpenGL is already in here. SFML uses OpenGL to draw its windows and to set up its environment. Okay. You do need to also tell it where the additional library directories are because the actual library files are in here. So in SFML there's an include, but there's also this lib folder, and this is where all these things actually are. So we need to do the same thing. We're actually going to do this for all configurations this time. Yes. We're going to do go up 2 directories, SFML-2.3.2, and then lib. Right, that's that folder. If I just write, oh, one more thing too, there is a define. If you're using static, that's what -s is. There's also -d. I didn't use the -d ones. So you can see there's /-s, -d, and -s. So any SFML, because I'm doing debug, these all need to be debugged. This is all necessary and important to get the linker errors out of the way. The next part here is that I need to specify, I think it's called SFML static. And I know that because it says that here. I'm just kind of skipping over all the tutorial stuff because I've done this before. I think that should be it. Cool. So now built, no linker errors, hit F5, and I get a window, right? This is the basis of what a game is. So now let's take this a little bit further. This is great and all, there's a green window, but let's make that thing bounce around. I think that's probably the best thing. Let's first make this thing a 720p game, right?
That resolution.
Right? Still has a green circle. What we want to do is make this thing into an engine though, right? We have this loop and this draw, so why don't we do that instead? So what we have here is that we can move this shape into draw here, and we can move this thing here into here. Draw can take our window Okay, and then this can go into update or loop. And I'm actually going to move this stuff here as well. I'm just rearranging the files here. And I know you guys have questions, so feel free to ask. I'm sure I just lost some of you guys on the pointers. Did I lose any of you guys on the pointers?
It's always on the pointers.
I feel like I understood what it did, but I'd never be able to do it myself.
Okay. Sure you can. That's
Not never, but like if I went home right now.
all I did was move functionality into a loop and a draw, right? Like this is all the stuff related to drawing. You clear the window, you make a shape, set the color to be whatever. You draw the shape and then you actually say display, which pushes the drawn objects to the front, to the window. It basically flips the buffers so that you actually see what you draw. And then here I'm just waiting for the escape key to be pressed. There's my red circle, right? And I can hit, I think this is, yeah, based on that. You can also do, because SFML has keyboard support, is key pressed? I can do things now like close the window on escape. Right? So I can hit escape and close the window. So let me just review what's happening here. This is our engine now. We have this while loop. This is basically the loop we had before, right? This window here is the window that we set to be 1280 by 720. The loop and the draw both need a window to do the work. All right. So why am I doing this? Does anyone have an answer for that? What happens if I don't do that? What is the difference between this and this?
You're referencing the window from the original call, I guess. I'm trying to figure out how to explain it, I guess.
Okay, let me we'll put a breakpoint here. It's actually very easy to explain. You guys have used watch windows before? If not, okay, this is going to be a new lesson too. Watch windows lets you basically do things like put a variable name in here. So I can put window in here. It lets me see everything that window has. Like here, the size is 1280 by 720. This lets me see that, oh, this thing is a window and it has these properties in it. What happens if I do this? What does that look like to you guys? Can you guys read that?
No. It's like a position.
It says that's an address. That's right. It's an address. It's an address into memory. This is basically, if I turn this off, this right here is a hexadecimal number, right? What is that number in? That's the hex number. It's basically this number. It's basically it's like 1 megabyte into the executable. That's where, that's where this offset is. It's 1 million bytes into where the executable is. That's the address in memory, which means if we can actually do this, go to memory. Okay, so this right here, this is going to be really confusing to you guys. This right here is basically like, you can almost think of it like the inventory system from like Skyrim or Final Fantasy. Basically, this contains everything that my program currently has. Like this is basically like a Diablo inventory in a way, right? Like each of these slots represents a different piece of data. The thing is that this is my window here, like about from here, let's just see here. Let's just see how big this thing is. It is currently 528 bytes, which means it's about, each one of these is a byte, so it's about 500 of these, let's just say, I don't know, around here. Somewhere in here is actually a number that represents 1280 by 720. Somewhere in here is actually a number that represents our value here. The thing is, this whole block is basically our window itself. And the reason why this is important is because when you put an ampersand in front of a variable, it gives you this address. Right? It gives you back an address in memory of what you can do. So what you're actually doing is saying, hey, loop, I'm giving you this number right here. Go ahead. It's as if I did this.
Could you do that?
If you cast it to be SF window, this is really bad. But that's essentially what you're doing. You're telling it, hey, there's a pointer to a window, to a render window. This is essentially what you're doing. This and this are equivalent. Like, I don't think you'd ever want to do this, but this is basically what you're doing. You're casting this value, and you're telling it that it's a pointer. That's all this ampersand is doing. If I don't have an ampersand there, let's just say I had another draw without an ampersand in it, that is the equivalent of taking all of this data, like pasting it here. Okay? That's the difference. When you pass an ampersand, you say, hey, here's the address to the window. This is what I'm passing you. When you don't put an ampersand in there, it's like, hey, make a copy of everything in this window and then give it to the function. The problem is the function, I've said, requires a pointer. So this won't compile anyway. I mean, this right here, this line wouldn't compile. All right? Okay.
But if you didn't set up the pointer, then it would?
If I had these not like this, you mean?
Yes.
Yes, it would copy it. The problem is, now you just made a duplicate of the window. You basically hit Control D, like in Unreal, or if you copy paste in Unreal or Unity, you basically now have two windows that are completely separate.
So
that's actually, so the way you get around that is you say, hey, make a copy of it, like do the thing that you normally do, but instead of making a copy,
just do it to the same one.
Yeah, modify the existing one, which is what this pass by reference is. Okay. But I don't like to do that. It's kind of ambiguous. I like to use pointers. Plus, this is just better programming practice anyway. Because you want things to not have, you want to allocate things on the stack as much as possible. All right. So that's like a super crash course in this. This is our engine so far. Let's make our engine capable of moving this shape around, right? So we're going to do one more piece. Right now we have this red circle. I want to be able to move the circle around with up, down, left, right. Okay. And let's say I want to have two circles in there. One that moves with up, down, left, right, and then one that moves with WASD. So you can have two circles, and they can just, one's green and one's red. The way you typically do that is, this is where all the input is handling, right? Like this is where I have is key pressed. So I could put like, oh, is keyboard pressed up. Then I can do something. I'm going to fix this up. Stop me if you have questions, by the way. This is the time to stop me anytime you have a question about something if you don't understand something. Otherwise, I'm just going to keep going. And the whole point of this is for you guys to ask questions. So I'm not doing this for my own sake. So I want to do something like move the circle up. What circle am I talking about? I don't even have a circle here, right? So what I'm going to do is I'm going to make an object here that actually has this loop and draw in it. I'm going to make, this is my engine here, but the problem is I can't like, this circle only lives right here. I can't access this circle anywhere outside of this draw function. So I need to change that. I need to change it because I need to both draw the circle and move the circle too. So I'm not going to do this in a header file or anything like that, but I'm just going to make a class here. I should probably do this in a header file, but I'm not going to for now. I'm going to call this thing the game. And this is a very common thing. You typically almost always have something that's like a game object in here. And this is where I'm going to put the loop. I'm going to put these functions here. And I'm going to put a draw. Okay. And this is going to live inside the game namespace. So is this. And then this now I'm going to make a game on the stack. Notice I'm sure you guys have learned, like, oh, you could do new game and stuff, and then like delete, right? You guys learned that stuff?
Yeah.
You don't need to do that here. You don't need to do new, because this, the lifetime of this object, this will get created right here and then destroyed right here at the end of the function. So I never need to call delete on it. What's nice is I can do this. Okay. Do you understand why I didn't do this? You guys have questions on why that's not happening?
Because the period is like calling the function.
They're both calling the function. That's the
This
difference.
one's going to a specific part of the function?
Not really. These two things do exactly the same. 99% of the same thing, right? They both say, hey, on this object, I want this function to get called, right? This object, I want this function. This object, I want this function. They both do almost the same thing. This is the arrow operator. So why does that work? Well, this thing is used in the case where you have a pointer, okay? If you had my game, watch the error, it jumps, right? See the arrow is now the squiggly is down here, because this is not used with pointers. This is used with objects.
Yeah, I don't know the arrow operator as well as I should.
It just means use it on pointers. Like literally use it when you have a pointer that you're using on. This is a pointer because you know there's a little asterisk there,
Yeah.
right? When it's not a pointer, use the dot operator,
Okay.
right? This thing switched now.
Yeah. Makes sense when you explain it. Every time I read about it, I'm like, I don't fucking understand this.
This arrow operator is used with pointers. That's pretty much it. The reason why I don't need to use the arrow operator is because there's no pointer here. Okay, and I'm going to blow some of your guys' minds, because you can also do that works. That's the same as this. Why does this work? What did I just use this for?
You're using a pointer before you the address.
Right, I'm converting this thing to a pointer. So this whole thing now is basically the same as a pointer,
Yeah.
right? That's why I use this operator here, because now the thing that I'm pointing to is a pointer, right? Okay, I'm gonna blow your minds again. This is what you guys need. Even bad exposure is good exposure. So now this is a pointer. Now I have to use that operator, right?
Yeah.
And my game loop, right? I have to use this operator, right? But I can do that. That is kind of like the opposite of that. This kind of has nothing to do with this. I know they use the same character, but this might as well be like $. Because these two, they're kind of related, but this has a different meaning, right? This thing here. Why does this work? What is this thing called? Anyone know? It starts with a D. E. It's a D reference. All right. This operator converts a pointer from a pointer to an object. Basically, it's like the opposite of this. Okay. This operator, the ampersand, the address operator, converts a object to a pointer. Okay. All right. Now that I've exposed you guys to hell, we're going to go back to the simple version, which is just this. This is why I like to keep it simple. This is basically C#, right? This is what you do in C#, with the exception of this. Okay, so now I have loop and draw. It should do exactly the same thing. Cool. This doesn't look any different. Why did I even bother doing this? Well, now I can take this guy here. and I can add it as a member. I can even call it mPlayer1. And instead of doing the shape here, I just replace that with mPlayer1.
And then you could do a player 2 with a different color.
Yep. And then I have a constructor here. You guys, constructors are guaranteed to be called when the object is created, so which means I can say mPlayer1 equals shape. SF, circle shape. Right? So this is me initializing that mPlayer1 to be a circle shape. It should still draw a red circle. I test this every time I make changes. Okay, cool, red circle's there. Now I can actually move this thing up, or I can move it down in this case. How do I move this thing down? Now I get my mPlayer1, now I can actually move this thing. So I can be like set position. I don't know, 5. Right? I can move it down now. The reason why I can move it down is now I have this circle that I can reference. You should never do this, though. You should never add static numbers. This loop, typically you need time. So I'm going to pass in something that is in SFML called time. Time is just a structure that has like seconds in it and lets you get things as seconds or milliseconds. And then there's a way you can get the delta time here. Create a clock. Okay, there's my clock. Cool. Okay, the reason why I did that now is I can go here into my loop and I can just print dt is I should see it over here. Whoa. Don't forget the /n. I always forget the /n. You guys see that delta time? That's how many seconds have passed since the last time I called loop. The reason why I need that is now I can do this times dt.asSeconds. Now, what does this formula mean? What does 5 times as seconds mean? Before it used to be 5. I used to move it 5 pixels every time I hit down. Now this is going to move 5 pixels per second. I can make it move 100 pixels per second now. Now that I know that my screen is 720 pixels tall, it should take about 7 seconds to move down, right? Oh, I didn't actually do... Position equals times... There's y. Oh, it's actually just moving super tiny. Should move it 1,000. This should be adding This is why printf is nice, because you just do stuff like that, and then you just be able to see how much it thinks is moving. I think my clock is actually not returning the real time. It's definitely been more than 0.01. Let me make sure I have this thing set here. Oh, this get elapsed time. I think my elapsed time is seconds. Oh, I see. I have to call this. There we go. That's better. Okay. Looks like it's still moving very few pixels per second.
You moved it back to 100 instead of 1,000.
Should still be fine.
Because it's a seconds and not lower variance.
This thing here is actually the time. Not the restart also returns so you can avoid a slight gap. You get to call it off time. So leave before starting. Update GameObject gaps.
Line trace by channel. See, I just want to clear out how to control the
You guys get to see a little bit of what the debugging process is too. Just trying to figure out like why the delta time here. Aha. This is wrong. Well, I'll pull event here. I need to move this stuff out of this while loop. There we go. This while loop here basically was looping to get every single window event. So you get events like closed. There's events like you lost the focus for the window, you press the key, you have a mouse wheel that moved, some other event changed, which means now that it's moving 1,000 pixels per second. Now this should work properly. Now it should take about 7 seconds to move down. .2 seconds to completely go down. It's important to have this kind of unit of measurement because you want your objects to move at a consistent rate no matter like what machine they're running on or how fast this loop is getting called. So this thing will always make it work that way. Right? And the way that I would actually do this too is that for each keyboard key, I would get the position, calculate the movement, and if it's down, I do this. Just copy 3 times, 1 for each key. Right, so that's minus, this will be left. Minus x. Okay. And we're going to do this. Make these all not part of the same if statement. So these all can happen at the same time. So notice here I have, you can move up and left at the same time, right? So now we have this thing where I can move it around. Not super exciting, but this is the basics of a game, right? You have an object that can move. I have this object here. I can even do things like give it velocity. Like I'm setting the position now because I'm moving the thing around. But there's nothing stopping me from making an object that has a velocity to it. Right? I can make player 2, and maybe player 2 smaller. And player, I'm going to move the color setting up here. And player 2 is going to be green. And player 2 is not going to move like this. I'm just going to have player 2. I'm going to get the position of player 2.
Oh.
Couldn't you just put the color in the class?
You could. There is no class, though, for these things yet. You can make one, but I haven't gotten that road yet. I kind of want you guys to take over after this, after I'm done with this. I'm going to get the position of player 2. I'm going to make the player 2 move 200 pixels per second. This will move player 2 to the right at 200 pixels per second. Oh, I need to also draw player 2.
How long those lines are there for?
There it goes. Okay. So this is kind of the basics of a super simple engine. There is a lot more you should do, like make a game object here. And the game object should actually have in it, it should have a shape. It should also have a color.
Now, could you also put the controls in the class?
You could put the controls in the class. I wouldn't though.
Keep it like universal.
Yeah. At least in this case, I'm not sure what the game is yet, so you'd have velocity. You'd have a class like this, and then you have something like a update on here on this object. And this is where now we start getting into like actual usable. Like right now, for every player, I would have to make another shape. If I wanted to make a ball, I would have to actually make a ball here. And then if I want to have like a player 4 or player 3, I have to continue to do this. But why couldn't I just have a list of game objects? So you guys know what a vector is? Anyone? It's an array. It basically contains a list of things. A vector is like a way to have a dynamic list of infinite number of objects. So I'd like to replace all this with this. The reason why I made this is now that I can have this thing here, I can actually make something that just loops over all the game objects and draws them. Like here, I could just have why couldn't I just have m objects at I dot update? Like that. Why is that important? Well, I could do stuff like this. I'm taking the velocity here, and I'm just taking that work that I was doing before, and I'm just moving it into here. Because I want lots of objects that spin around, right? I have this update loop that's getting called. Now what I can do is I can do things like have a function here that takes one of these guys. all I'm doing is setting the velocity equal to the velocity I pass in. The reason why I'm doing this will all become clear in just a second. I'm going to go all the way down here. And in my game, in the constructor for my game, I have my players and stuff. I'm actually going to delete player 2 and this and this. I'm going to delete all that stuff. All this stuff is still here. Delete drawing player 2. I'm actually going to have this be a loop as well. I can actually just take this loop and add a draw function. I'm just basically duplicating what I have inside the game. And here I do window, draw, and shape. And this thing will take a shape and a color. This is called an initialization list. It takes these arguments and shoves them into here. So it takes a shape and puts them in here, takes this color and put them in here. Okay. The reason why I need that is because I need a way to set the velocity and the color and the shape of objects. And now finally, I can make 100 different objects. So I can take this. Now these are going to be pointers. New ball. I have these guys all start at I'm going to put them in a random position. I don't know, from 0 to 1280 somewhere. And from 0 to 720 somewhere. Okay. Pass in a shape and then SF color. I don't know. Let's make them all blue. And then we're going to set new ball, set velocity. We're also going to give them a random velocity. Maybe I give them a velocity between zero, maybe between negative 100 and 100. And then finally, the way you add objects to a vector is you do a pushback. Okay. Okay, so let's put comments here. Set the shape to be a circle. We're going to make it be, I don't know, another random number, a random circle size from 0 to 100 plus 50. This one is set the circle to randomly be somewhere between 0 to 1280 and 0 to 720. Okay. Blue. Make a new GameObject. And then set the velocity to be randomly between -100 and 100. Okay. Add the object to the list. Notice I had to change that from a dot to an arrow operator because there's our pointers. All right, so let's just step through here one bit at a time. I'm going to put a breakpoint here. Breakpoints are really useful for this kind of thing. You can see here on the left it's stopped execution. It's going to loop through this thing 100 times. So this first thing it's going to do is going to make a shape here. The shape has a radius of 30. And the position of the shape, see where the position of the shape ends up. I got to do, anytime I have float ran max, I got to do that. This returns an integer. If you guys ever divide an integer by an integer, you'll almost always get 0 if the bottom denominator is bigger than the numerator. So here's the shape. So now the radius is there. Okay. And now the position should be something a little bit more random. Here, 247 by 405. That seems pretty random to me. The velocity here is also random. 17 by 61. I know it's hard to see, but it says 17 by 61. I can add a watch window here. Okay, that's a 61. That's the velocity, how fast the ball will actually move. Okay. Okay. Then we add this thing to the list. This list has one object in it now. At the end of this function, this list has 100 objects in it. This is all the balls that I've just added. They all have random radii, they all have random positions, and they all have random speeds. Okay?
Now they have maximums as well, right?
Maximums as in?
Like as in size.
Oh yeah, they have a range of size. Because remember, the size here is between 0, this right here gives me a number between 0 and 1. Randomly, I multiply it by 100 and I added 50 to it. And then here, in the loop, it's going to go over every single one of my objects. And here's the function I wrote earlier. Get the position of the object. Currently this one's at 247 by 405. Add the velocity, and then set the position back. If I play it, let's try this again. Let's make the colors a little bit random because I can't tell what the hell's going on. Right now the colors are blue, but that doesn't mean I can't make it be random, right? I can set R be equal to again a random number. I think it goes from 255. Looks like these are floats, so I don't need this.
Are they being assigned to those objects?
I think this random number, these colors here, this is where I debug. This is why setting breakpoints is super. I can just put a breakpoint right here and figure out what the color is. Looks like it's not setting it to be. I think these are actually supposed to be. Oh, in the alpha. Oh, and I don't think I ever set the color in the constructor. Maybe I do. But I never actually set the color here. That's right. I actually need to take my shape, fill color, I never actually did that part.
I still can't tell what's going on.
It's too much stuff happening.
I mean, you made a screensaver.
I did make a screensaver. The nice part is that right here I can change it from 100 to 1,000. I can have 1,000 objects in here, right?
How many does it take to crash?
It can handle a lot. So with cache hits, it'll be pretty fast. This is 10,000 objects on screen all moving. They'll eventually all move out of the way, right? This is how many our engine currently can handle, right? We're talking about the engine here again, like how many it's actually drawing.
Can it do 1 million?
Probably. Let me shrink down the size of these things a little bit. I'm going to make them between a little bit smaller. We can do 100,000. See how well it does that.
Perhaps saving?
Oh, I save. It's all saved. It's currently probably making all the objects right now. This is 100,000 objects. Okay. We can probably speed this up a little bit because I'm not doing things the most efficient way right now. So I could do these const right there. This is also fine.
What is const?
It's a hint. It basically means you're not allowed to modify this thing, this variable that's passed in. But it's more of a hint to the compiler to say, hey, this thing, because you're not changing it, you're allowed to make these things a lot faster. Plus, I'm running in debug. So when I run in release, oh, I didn't set up my... One thing to remember, too, is that, remember I set this thing up for debug here. I actually need to do this for release now. Go here, just fix up all these things instead of -D.
And now we have great conversations and arguments.
Yeah, my dad is
Debug is orders of magnitude slower than release, but debug lets you do things like see the status of every variable much faster. So this will be 100,000, so you notice it started up a lot faster that time. I just hit F5 and it actually just ran almost right away. So I think we can do 1 million.
Let's do 1 million.
It's one more order of magnitude. It'll probably take just as long as debug took to start up. But I bet you the frame rate will be much, much slower.
One could imagine.
Well, yeah, I mean, you're older than 13 minutes. Looks like it's from the new Jurassic Park movie.
But now, is it because of each individual object or the size of the object or a combination?
It's mostly because how many objects we have than each object being... The objects themselves are dead simple. They're not doing almost any work. So right now, the work that it's doing right now is allocating memory. The reason why is it's like as I'm running my program here, you can actually see the usage of memory for AP Engine going up. You guys see that?
Yeah, that's
It's using 2 gigs of memory right now.
pretty good.
And all that memory is just from, it's just for the data for the shape and the color and the velocity. So this is 1 million objects right now.
Now, and then
Looks like a Damien game.
Yeah.
Like here, play this.
Now it's actually that memory usage is completely related to how many objects we have, right? That was 2.3 gigs of memory, and here now it's literally 10 times less. You guys see that? Because I have 10 times fewer objects. So if I divided it again by 10, you would expect that to be what? 10 times less as well, almost, to a certain point. Yeah, 55 megabytes. That's pretty good. 10,000 objects. Hopefully your game doesn't need any more than like 10,000 objects. Yeah.
well, these are 2D.
Yeah. So I want to give you guys this. What you typically need to do is you can make a game this way. And I think you guys can use this as a framework for basically deriving some of your own games there. I still have my player object in here, which I'll leave. But now, anytime you want to add more objects, you can add them here. Or you basically can make other types of objects that have bouncing behaviors and other properties to them. But this is our engine. Basically, we can start drawing. And because it's all in SFML, it supports all the things that SFML does. Like if we wanted to have these things actually have textures on them,
So since it uses some OpenGL and stuff, it has like shaders and crap like that too.
it does. Yeah.
Nice.
You can do shaders as well. You can actually start writing OpenGL code right now. So there's a way. So I think, Cody, you can see there's actually a port here where it actually calls GL draw. So here's GL draw.
Yeah.
Here's like GL clear. This is basically using OpenGL to like draw stuff here. You can just write OpenGL code directly there.
Oh,
It'll work.
that's cool.
There's plenty of people who do
So okay, so what I'm going to do is I'm going to put this whole thing up on Zool. You guys don't have to use it. It doesn't matter to me if you don't even use it at all. But I think if you have an interest in making this thing work, you can. You need both of these things. I'm just going to combine them both into
How large is the file?
it's just like under 50 megs.
It's like you replace the dialogue with the person.
100 megs. Most of that's probably because I actually built all this stuff here. You don't need this. You don't need this. You don't need this. That's about 80 megs. So, anything else you guys want to know how to do while I'm here? Is there anything specific that you're curious about how you do in C++ or in games specifically?
So the processor is taking the brunt of making those objects, right?
Yes.
The memory. Is there an easy way to defer that to like a GPU?
Not an easy way.
Okay.
That is the eternal question.
Because
You want to try to do stuff on a GPU where you can. It is significantly faster
Right.
at certain things. Not everything is meant to be run on the GPU though. GPUs have a lot of floating point units. They can do a lot of math operations per second. So things like calculating velocity or adding position or calculating collisions in very few cases can be done very quickly on GPU. But things like making objects, that's just going to be that has to be on the CPU for the most part. I mean, you can make that stuff on the GPU too, but like typically you're going to want to move that stuff around with a keyboard and you're limited in a lot of ways. And like there's really why would you want to do that? Like what's the point? What game are you making that needs that, right? Any other questions?
So on that site, does it have all the documentation for like all the functions that you can use?
It has these, yeah. It's basically like, oh, what do we want to do? You want to draw text? Okay, here's how you draw text, right? Like it loads a font.
Shows, like what functions it has and stuff.
Yeah. Shows the things. It just gives you code that you can use, right? You can scale, transform entities. So you can like rotate stuff in here. It's all 2D stuff, but it's all like C++ and it's all actually still pretty relevant in 3D. A lot of stuff you do in a 2D game, especially with regards to like calculating aim vectors, velocity, that stuff doesn't really change that much in 3D. You still are doing it, you just have one more axis. The things you don't really do in the SFML that you do a lot of in 3D is dealing with matrices, but that's something you can always add later.
Yeah, I don't know anything about that stuff really.
I don't think you need to worry about it for now. There is support for that in SFML. But basically, this is a transformation matrix.
Yeah.
But you don't really need it too much. But you can totally make, a lot of games are made in SFML, like that are like Ludum Dare games and like other 2D games. This thing basically gets rid of the barrier of entry. Like you can now draw shapes. Like there's nothing stopping you. This is a circle shape right now, but there's nothing stopping you from making something that's like a rectangle or even just a line. Right?
If I do this correctly,
Now all the shapes are predefined, right?
For the most part, there is a polygon shape that you can have that lets you define whatever like verts and lines that you want. So.
now you laugh. Wouldn't that just bring
Are you able to add your own shapes?
You can. It's ultimately it all draws to the same place. What shapes are you thinking about?
you get there?
It's just the concept of it. Like, is it within just the? I mean, yeah, at the end of the day, it's C++, so you can.
Either the shapes that are all possible shapes can be represented by either a circle, a square, or an ellipse, a rectangle, or a polygon shape. And you have access to all that stuff, so you can make a star shape if you wanted to, or if you just wanted to have like an irregular shape, then you can. All right. Any other questions?
By any chance, you have a micro USB here?